Thank you very much, everyone, and welcome everyone to this amazing conference. It's great to see so many familiar faces and new faces here today. Let's get my mouse out here and start this up. There you go. Is that working? Yes, excellent. Okay. So my name's Andrew Tridgell. I'm sometimes known as the systems lead for RGPilot, which is just a catch-all for, you know, if somebody else isn't responsible for an area of RGPilot, then I sort of am the backstop. So what I'm going to be doing is giving a bit of an update in my talk about what's been happening at like the systems level, some of the new features that have gone into RGPilot over the last year. And as you might have guessed, it's going to involve a bit of a demo. So towards the end of the talk, I am going to be risking the ire of the demo gods by trying a fairly ambitious demonstration, which all of you are going to be involved with. Yes, anyway, more of that later. So each year I normally give a bit of a summary as to what's been happening in the RGPilot world. And as always, it's been a very active year. We've had, you know, over 5,500 patches have gone into RGPilot last year. About 2,600 pull requests have gone through, which you think of in terms of a just declining that call from random person in London. You think about the sort of the rate of sort of, you know, changes per day or per week. It really is quite an amazing development rate. And all the people you see around, the developers you see around you, they're the ones that keep things ticking along like that. Over 900 wiki changes have gone in the last year. Huge thank you to our wiki maintainer, Henry Wurzburg, who's done an amazing job. Over 200,000 lines of code have changed, 265 contributors in the last year, which again is absolutely fantastic. We try to welcome new contributors and we keep getting more and more coming in. And 77 new board ports. So 77 new boards of peripherals or flight controllers or whatever just in the last year. We're now up to 392 different hardware definitions in our tree, which is really just huge. So I'm going to be highlighting some of the new features. I can't, of course, show all of them. There's been thousands. So I've just picked a few ones that I'm particularly familiar with. And then I've created a demonstration at the end where I have tried to cram as many of the new features into one demo as I can. All right, so one of the new features is around protocol capture. Oh, by the way, in my talk and any talk I'm giving, feel free to put your hand up and ask questions during the talk. I want it to be fairly informal. I don't mind at all if we steer off a little bit into some weird by topic. That's absolutely fine by me. We have, I don't notice your hand, just shout out. So we have two types of new protocol capture over the last year. The first is CAN protocol capture. We've had this in Lua scripting for a while, but it's now a generic feature. And what it means you can do is you can just set a bit, the CAN, P, and options bit, so one for each bus. And what it will do is log every CAN packet, be it BSCAN or CAN-FD. Doesn't matter whether it's drone CAN or, you know, KDE CAN or whatever. Any CAN packet will be logged into your bin log. And the reason this is particularly powerful is for analysis. So often people want me to write a driver for some new CAN peripheral with a weird protocol, and I can get them to capture all the traffic to the bin log, and then they can send me the bin log and I can see exactly what's going on. But paired with that, we also have playback scripts. So we have both a Python playback script, which can play back that CAN traffic into our simulation environment, which allows us to then develop a driver against hardware that we don't have. For example, somebody might have some new CAN EFI driver for a EFI engine, and they do a bit of capture of the traffic of that on their hardware, send me the bin log. I can play that back into the simulation environment and write the driver in situ without having access to the hardware, then develop the driver, get it working, then send them the driver to test on the real hardware. Very powerful technique. Now, the photo down here, if I try not to trip over the cords, the photo down here is a different use of this sort of playback. And this is one of our ArduPilot partners doing playback of CAN servo traffic. And this is for doing longevity testing on servos. So when you're shipping vehicles, it's getting more common in the world of ArduPilot to have very long endurance vehicles. And when you've got a vehicle that can fly for many hours, then you've got to make sure that your servos are really going to last. And so this was being done with the newer race Phoenix that you might have seen. What they're doing is a little test rig. This is one of several test rigs they've got that are playing back the CAN servo traffic to give exactly the same actuator values on the CAN servos that they had in a real flight. And then they run that in a loop for days and days and days and days to make sure the servos are going to last. Very, very powerful technique and terribly easy to do. So the next one I'm going to show you was network capture. So ArduPilot, of course, now has native networking using lightweight IP. So we have both native Ethernet. So when you've got a flight controller with a native Ethernet port, which is getting more and more common these days, and we've got PPP support where you can have a serial port running at high bit rates, typically 12.5 megabit. That allows you to then gateway a flight controller without Ethernet onto an Ethernet connection. And so we have built-in packet capture on both Ethernet and PPP. So this is very useful when a vendor, for example, has an interesting camera and they're having troubles with the connection with ArduPilot's camera support. And you can ask it to capture all of the network packets from the point of view of the flight controller, exactly the packets that are going in and out, into a Wireshark PCAP file, and you can then view that in Wireshark. So I'll just flick across to a Wireshark window that I've got here. So this is a Wireshark window that is capturing some Mavlink traffic. And of course, we have an auto-generated Wireshark Mavlink parser. This is useful not just for Wireshark. You can use it for RTSP and other camera protocols, whatever network protocols you like. You have the full power of Wireshark available, but it's particularly useful. And you can see here, so there's a servo output raw. And if I can move the mouse, there's all of the values going out to this. This was a rover, so it only had 2 outputs. Not sure with the font size whether you can see that easily. Just see if the font can go a bit bigger. But very, very powerful technique for doing network analysis. And often it's difficult to get a Ethernet cable into the right portion of the vehicle to see the traffic from the point of view of the flight controller with switches, etc. Now you can tell ArduPilot to capture directly inside the vehicle. Like many of these features that are less commonly used, this particular feature is behind a define where you enable it on the ArduPilot custom build server. Many thanks to the great efforts of Sheev working on the custom build server. He's done a fantastic job. And so this is one of those features where you enable it in the custom build server or at the configure command line, put it on the controller. I'll just show you what that looks like when you're capturing. So I have here Mav proxy connected to this little rover here. And if I set param set net options to 128, then what you see is it's a little message there, not sure you can see it. Capturing to PPP0.cap, capturing to PPP1.cap. So that's capturing all of the packets at the PPP level, which means you can actually see all the IPCP and other PPP transactions going on in case you're debugging things at that level. Plus Wireshark decodes it all the way up to the UDP, TCP, high-level protocols, in this case, Mavlink. All right, so I'll just pop that back, turn that off again. And any questions about that before I move on? I'm happy about network. All right, let's go on. So another thing that has happened in the last year, we have some fantastic work being done by Hoybeen. Hoybeen, put your hand up. There you are, in the middle there. So from BIM Drones, he's done brilliant work creating a web-based drone CAN GUI tool. Some people really struggle with the installation or running of the Python-based drone CAN GUI tool. And there's a nice one built into Mission Planner, but if you're not using Mission Planner, then it's nice to have this alternative. Excuse me while I collapse up here. So there's now this very nice, and what I'm going to do is show you a live demo of this. So here it is, the OwnCAN GUI tool. And I'm going to connect it across to a SSL. So this is now connecting to this drone using encrypted WebSocket to make the connection across an LTE modem attached to the vehicle here, and I'll talk more about that in a minute. And so we have here a here for there, and we could go and, fetch the parameters from the here for, should be able to fetch that. I'm not going to debug things right now, but we have the here for there displayed on the CAN bus, and you can switch buses and things, so you can go to the other bus, and this should come up and start displaying there, and it's not, and I'm not right now. All right. So back to, any questions at all about that drawing tool? All right. So support proxy. So the support proxy, I talked about this a bit last year, but it's really completely changed for this year. It's had a massive overhaul. And some of you have used the support proxy. Those of you who've used it have probably mostly been using it when one of the partner support engineers is trying to help you out with your vehicle. And that in that mode of operation, typically the end user has a UDP connection to the support proxy, and then the support engineer attaches also the UDP to see the traffic on vehicle. They're able to provide remote support attack. So that was how things worked up until a few months ago. It was UDP only, single support engineer, single vehicle. And the thing that I've been working on over the last few months with the support proxy is to expand that to have much, much broader utility. And what I'm hoping to do is to get more of the ArduPilot user and partner community using it as part of their normal operations. And so you can install your own support proxy on your own cloud server. Pierre, do you want to put your hand up? Where are you? Pierre. So Pierre's done some wonderful work with the installation scripts to make it, and instructions to make it very, very easy to install your own support proxy. So you might wonder why you would want your own support proxy. So using the ArduPilot support proxy allows, if your vehicle is internet connected, it's got some sort of IP connection out to the internet. In this particular case, I've got an LTE modem to allow it connect up to the internet, but you might have some other type of, IP connection to the internet. Then you can have multiple ground station operators connect via the support proxy to that vehicle. And so you can have a normal ground station connected. In my particular case, I've got MAV proxy connected here. And the big difference that with this year is now it's not just UDP. We support any mixture of UDP, TCP, WebSocket, and encrypted WebSocket, WebSocket SSL, also known as WSS. So that means that your vehicle can connect with a encrypted WebSocket link up to the support proxy, and your ground stations can connect to the same support proxy using also an encrypted WebSocket link, and with Mavlink signing for authentication. So you have an encrypted and authenticated connection to your vehicle going off your own support proxy. And all of this is available in the increasingly incorrectly named UDP proxy server, which is what we called it originally, and that it's grown a lot more capabilities. So it now supports up to 100 simultaneous connections. So you have the traffic going from your vehicle's support proxy, a single Mavlink stream, being spread out to up to 100 clients connected. So this means you can have web-based tools connecting into your vehicle for doing particular special purpose analysis of the vehicle, displays. If you've got, VIPs and you want to have a big display as to what's happening on your vehicle, you can have a special purpose display for them via this encrypted WebSocket connection, but simultaneously have other ground station operators that are connecting with a more fully featured ground station, mission planner, MAV proxy, QGC, whatever, all connecting in at the same time. But the bandwidth usage from the vehicle onto its internet connection is only one stream. And that is then being forked on your cloud-connected server, which makes it very bandwidth efficient. So paired with that, it's also video streaming. Yes? It's arbitrary. It's a number. It's a hash define. I could push it up to 200 or more. If I've used a uint8 at the moment, so if we want to go over to 256, I'm going to have to do more. But yes, the 100 is just arbitrary. I chose the number 100 as the limit because I was told there would be about 100 people in the audience here. And so we're going to try in a few minutes having all of you connecting simultaneously to this vehicle. And we're going to see how that goes. I'm expecting chaos. But we will see how that goes. And of course, some of you in the audience, here's looking at you, Tom and Peter and others will, of course, open 30 tabs simultaneously to try to push that number up. And some of you will discover the reboot button, and please don't press that, at least at the start of the demo, but we're going to have some fun. Yep. So the way they are at the moment is they're read-write, but you need to get their own system ID, component ID, and then you can do the limiting within the vehicle. But I've decided not to for this, just to maximise the fun. So all of them have, so please don't tell it to, reset all parameters to defaults and that sort of thing. I know you could do that, but you don't have to demonstrate it. Yep, Ryan. No, the amount of traffic. So I'm going to be getting onto the LTE modem stuff in more detail in a minute. But no, the amount of outgoing traffic is the same no matter how many people are connected. But you do get all the heartbeats coming from all the ground stations. So that increases the uplink traffic just for those heartbeats. So you end up with like 100 heartbeats a second going in, which isn't very much. The question from Ryan was, how does the traffic over the LTE modem increase with the number of people connecting? And the answer is that it basically doesn't because it's splitting the traffic at the support proxy. So anyway, for more details, how to install your own, etc., you can read the marvelous documentation from Pierre at support.rgpilot.org. But some of this might become a bit clearer as I get further on in the talk and start showing the demonstration of how this works and show how you can do video over this as well. All right. So JavaScript Mavlink bindings. So all the world's going web UIs, and many thanks to Pete Hall. Pete, where are you? Pete, up the back there. Everyone knows Pete. So Pete's been leading the charge on the web tools repository within RGPilot. If you haven't seen the RGPilot web tools, you really have to. In fact, I'll just go and go to the web tools. So this firmware.rgpilot.org/tools/web tools. We should probably just make it webtools.rgpilot.org actually, and make that a direct link. There are some marvelous tools in here that are just, the sort of thing you use all the time. I love the log finder. That is absolutely brilliant, Pete. It was a lovely piece of work. But there are some absolutely brilliant tools in here. Hardware report. The filter review is something we use all the time when tuning people's vehicles. There's a whole bunch of work in progress tools under here as well that are worth having a look at. So back to the talk again. All right, so back. Okay, so with these web tools, now the web tools that Pete's been working on, he's been concentrating on tools that analyze ArduPilot log files, right? So you load an ArduPilot bin log, it parses it very rapidly, and it provides ways of viewing that log in different ways, doing analysis, statistics, filter construction, etc. So the part that Pete introduced using real-time Mavlink into the tools with the talk he gave last year in Japan, which was the telemetry dashboard. And that was a really nice way of constructing interesting dashboards for your vehicle, but it was one way. It was just receiving Mavlink into a web tool, but it was using WebSocket, but it wasn't sending out from the web tool back to the vehicle. What I've been working on over the past few months is extending that so it's bidirectional. So you have really good support for sending Mavlink packets. And this builds upon work that people have been doing for years in our Mavlink generator, MavGen, as part of PyMavlink. So I'm sort of building on the efforts of others, which is a great tradition in the ArduPilot world. But the main thing I've added is robust Mavlink to signing support and SSL support, which means it's now really easy to create a web tool that will do an encrypted link into a vehicle and allow you to do arbitrary Mavlink operations, create your own ground station-like interfaces or other specialized interfaces for monitoring. And combine that with the ability to have many connections going into the vehicle all at the same time without increasing the bandwidth cost on the vehicle, you end up with a very, very powerful system. So this is just a little snippet of JavaScript code. So this is doing a send command int. So a command int is one of the fundamentals of Mavlink in this particular one, I'm doing a set mode call. And it's very easy to do this type of JavaScript work. So it supports both command line operation using Node and also in-browser support. And it's been tested with, the full range of browsers. So, both the Chrome and Firefox and Internet Explorer and mobile devices, iOS mobile devices, and Android all work correctly. All right. So LTE modem support. So as part of this effort, I wanted to be able to support beyond visual line of sight operations with very low cost, very low power, and very easy to set up and low weight solution. So what I wanted to be able to do was get a beyond visual line of sight connection from a vehicle without having to have a companion computer. And so the solution I came up with that was to ended up buying 15 different models of these little tiny LTE modems, which sell for between sort of $20 and $50. Very, very cheap modems available all over the place. And there's little tiny ones as well. So I've got, if you want to see them later, I've got, I've got about maybe a dozen modems here of various sizes and sorts. So these basically take a SIM card, and many thanks to British Telecom for providing an official drone SIM from BT for this talk. But I've also been using a lot the hologram SIMs that work very well worldwide. I highly recommend those. So with these little modems, I wanted to be able to have an LTE connection from a flight controller without having a companion computer. Because on some vehicles, you don't want to pay the cost in terms of weight and power and wiring complexity. So you want BVLOS operation and reliable communication without having to have a companion computer. And I know, of course, you can put a Pi Zero or similar very, very small companion computer, but there still is a cost in terms of the wiring complexity, the setup complexity, the power cost, etc. And so I wanted to be able to have LTE communication without a companion computer. And so what I did was I built upon some very nice work that Thomas did. Thomas, put your hand up. So Thomas did some very nice work where it's possible to create a virtual serial port within Lua scripting. And that makes the possibility of a Lua script that can create a serial port that implements the necessary APIs to talk to the modem. And so that's what I'm running on this vehicle. So this little rover here, and many thanks to Reese for providing this rover. I was planning to do this all in simulation, but Reese happened to have a wild thumper here with him. And so there's the little modem here sitting on top of a Cube Orange. So that is a SIMCOM SIM 7600EH LTE Cat4 modem on top of this little vehicle. And it's the only communication path into this vehicle. So what we've got is a Lua script that implements the modem connection using the AT command set and the GSM 0710 muxing capabilities to allow it to have multiple connections over the one UART. And that can create either a PPP link or a UDP TCP connection to the internet. So we support a whole bunch of different chipsets. I really got into this in a fairly deep way, and I basically started buying lots and lots of different LTE modems. I think I own something like 16 different LTE modems of various sorts. And then I've been writing drivers, and all of them are a little bit different in the driver they need. So the main ones I've been working on are the SIMCOM and the Quectel variants. But I've got a couple of other brands of chipset as well that I've got working. And they each have their own pluses and minuses. But there's a picture of the ones that I happen to have with me here, but I've got a whole bunch more back in Australia. I didn't bring all of my modems. And you can see there's a whole lot of variety of these things. They are very much, solder it together yourself. One of the things that I note at the bottom, I would love to work with a hardware vendor who might like to create a variant of one of these LTE modems that is specifically targeted at the ArduPilot community with JST-GH connectors, the level shifting done correctly, good power. These are quite power sensitive, that type of thing. So if there's a hardware vendor that wants to do that, then Tim? I'm just doing the LTE Cat 1, Cat 4 and Cat M at this stage. Haven't tried any of the others. I am looking at the possibility of doing Cat 12. 5G is a very broad term, but short answer is no. Just the LTE Cat M, Cat 1, Cat 4, and I've also done a little bit of NB-IoT, which is the really low bandwidth variant, and got some chipsets working with that as well. So, but I'm concentrating on Cat 1. So those who don't know the different categories of LTE modem, the main ones for this community would be Cat M, Cat 1 or Cat 4. And so Cat M is lower bandwidth, longer range, a bit better receive sensitivity. It's about 6 dB better than the Cat 4. Cat 1 is sort of halfway between, maybe 3 dB better than Cat 4. And Cat 4 is the highest bandwidth, but a bit shorter range. And because I'm including video streaming on this, I've actually just got a Cat 4 modem. And I thought, given I'm going to try and get all of you to connect simultaneously, why don't I go for a slightly higher bandwidth modem? And also the cell tower is like in the next field. So it's pretty close. So it pairs very nicely with the ArduPilot support server. So the way it works is you configure your modem either with a UDP or TCP connection straight to the support server, or you set up it as a PPP server, and then you use the net key options in ArduPilot networking options to have multiple network connections off to the ArduPilot support server, and then you connect to your vehicle via that. And the latency is surprisingly low. I've been using the support server on the east coast of the US for doing flights in Australia, and we end up with about 300 millisecond extra lag by bouncing off the support server for our BVLOS flights, which is really quite acceptable when you're flying a big quad plane. 300 milliseconds might matter for Andy with his FPV drones, but less important for the sort of flying that we do. So, so that's basically LTE modem support. I should mention, by the way, that most of people's issues with deploying these come down to two things. One is power. They can be quite power sensitive. So I've actually got a separate BEC for driving this particular modem, and it makes it much happier. Thank you, Reese, for having that extra BEC sitting on the top of the Wild Thumper. The second thing is the level shifting is quite interesting. So the chipsets are natively 1.8, most of them are 1.8 volt native, but the little carrier boards, these little green carrier boards, have a couple of transistors on them that do some level shifting up to 3.3, but they do it very badly. And so when I get traces on my Saley and analog traces, I frequently see that this supposedly 3.3 signal is actually coming in at 1.9 volts, and it often gets ground lift up to 0.7 volts, and that's getting really marginal. And so at the moment, I'm only running this modem at 460 kilobaud, which is the highest I can sustain reasonably on this Cube Orange. But with the right level shifting in place, these things, like this particular model will do 3.3 megabit, which gives you quite a decent amount of bandwidth, into your vehicle. We just need to get the level shifters sorted out to be able to push it up to those rates. But you can get really quite good transfer rates across LTE, once we sort out those types of issues. The actual chipsets themselves are dirt cheap. If somebody is looking at making one, probably Quectel. They're a little more responsive on the engineering side. They make some very nice chipsets and very good data sheets and things. And I could provide recommendations on chipsets if you're interested in making one. All right. So, any more questions about LTE modem support before I move on? Yep, Brian again. So the question from Ryan was, with NB-IoT connection, can you use normal MAVLink, or do you have to use the low bandwidth, high latency stuff that Stephen Dade has done a lot of work on? It does have enough bandwidth, even with NB-IoT, to do 2 or 3 hertz of all messages on a fixed wing aircraft. So there is actually a fair bit of bandwidth there. The NB-IoT, however, is designed more for static cases. So it doesn't do the automatic switching to the best tower, and which can mean it can get locked onto a poor tower connection when the vehicle is moving. And there doesn't seem to be good AT commands to say, hey, why not renegotiate there? You might have to actually reset the modem to get it to lock onto a closer tower. So there are some limitations. It's more designed for static Internet of Things sensing in one location. It's not really designed for a moving vehicle. So I've done a little bit with NB-IoT, but not much. Also, a fair number of the towers in my house in Canberra, I've got a tower right nearby that I should be able to use NB-IoT with Telstra, but for some reason, it will, when it connects with NB-IoT, it connects to a tower on the far side of Canberra and gets terrible connection. And apparently the telcos tend to sort of shape things so they turn off NB-IoT on some of the urban ones that have higher traffic. And so I think for most people, for most cases of telemetry, you're better off using a Cat1 modem rather than a Cat-M rather than an NB-IoT or a Cat1 modem. Question up the back? So Cat-M is more for things that move. Right. All right. Might need to get people to talk to you a bit later. I think most people can't hear you. We don't have a roving mic. So, yeah, but thanks for that. And we maybe have a little breakout LTE group later. We can have a bit of a play. Any more questions about LTE before I move on? Okay. So, related to this is we now support multiple PPP links. You can have up to 3 PPP links on your flight controller. And that's important because you might have one talking to Ethernet and another PPP link talking to a modem, and then a third PPP link to another modem or another device. So PPP gives you the universal serial to IP translation layer. So we now support up to 3 PPP links. We also now support configuration of routes. So you can actually control the routing between your Ethernet and PPP links. So you can control that this IP address, this target with this net mask goes out this link. So we've got an API in lieu of scripting that allows you to control the routing on your vehicle. So we now have ArduPilot as an IPv4 router, which I think is really exciting. Yes, so we now, you can combine the multiple PPP links with native Ethernet. So you could have a native Ethernet and 3 PPP links if you wanted to on your vehicle. Yes, indeed. You can route things through. So I got a question this morning of whether you could use this to route through an SSH connection, for example, to your companion computer via an LTE modem attached to the flight controller. The short answer is yes, you can, but you'll need a reverse proxy for your SSH on a proxy server to do that. But yes, you can route things through and set up your routes to get to your in-vehicle networks via the external network. Yes. All right. Any more questions about that? Okay. So, what inspired all of this work? So, at the start of the year, I got back into sailing. I learned to sail in the late 70s, dinghies, windsurfing, that sort of thing. And I started sailing again at the start of the year and got really involved. And then, horror of horrors, winter arrived and the sailing season was over. And so, what am I going to do down at the sailing club over winter? So, I thought of a winter project. I would follow along behind the many other people in the ArduPilot community and create an autonomous buoy. So we could have a buoy out for the racing where the boats go around the autonomous buoy and you can move it around on the lake. So you can see here on the left is my autonomous buoy, which you can tell was created by a software engineer getting the cheapest parts. And I'm not much good with hardware, so I bought a boogie board and a plastic lunchbox and a traffic cone and some Velcro, and hey presto, you've got yourself a autonomous buoy. A couple of thrusters cheap thrusters I got off AliExpress. So this is, last weekend, this is the buoy being used. And this tiny dot behind the third sailing boat there, that's the buoy out deployed. I should have got better photos of it. But that's us. We were doing training for the uni nationals last weekend, and they were using the autonomous buoy as one of the marks, and we were moving the autonomous buoy around. So that was sort of part of the motivation. So what do you need to do a good autonomous buoy? Well, it has to be extremely easy to use for anyone in the sailing club, right? I'm the resident geek in the sailing club, the computer science type person, but I had to make it easy enough that the other members of the sailing club could use this autonomous buoy without me being there, right? So it had to have a very, very simple interface. I wanted to have no special ground equipment, no ground radio. So no RFD 900, no transmitter, no receiver on the vehicle at all. Just the LTE telemetry for everything. And throw it in the water, press go, say go here, and you're done. And that led to wanting LTE connectivity and a web UI that would work on a phone. It had to be a user interface that would work on a phone that was inside a waterproof cover, right? So when you're out on the rescue boat, you've got these waterproof covers on phones that make very imprecise the movement of your fingers on your phone. So it had to be big, chunky buttons and very simple, robust interface for people to be able to move the buoy around. I wanted it to have automatic RTL and docking, so it would come back and dock itself back at the sailing club jetty, and then sit there and then wait for you to be brought out of the water. We've got a little lure script on board, so if it all goes wrong, the person in the rescue boat just lifts it out of the water, and as soon as it sees roll over 90 degrees, it disarms, right? So no need to use anything on your phone. Just pull it out of the water, stick it in the boat, and it's done. And it needs to be on like burley grip, which is really expensive. And very close to the water, normal radios would get changed. So again, long range. All right, so this is the architecture of the buoy. So what we've got here is a flight controller. So maybe I can even use the little mouse. Does that work? Yeah. So flight controller down there in the bottom left, and that flight controller is connected to via a PPP link to a BotBlock's drone net PPP network switch, which gives it access to networking within the vehicle. And then that network switch is connected over Ethernet to an IP camera. And sorry, my clip art isn't exactly right, but the IP camera you can see on the front of the vehicle here. It's just a little cheap camera that I got off AliExpress, but it's a power over Ethernet IP camera. Then there is the flight controller is also connected to an LTE modem over PPP again, and on the flight controller there is a Lua script doing RTSP video relaying. So this means we're actually piping video via the flight controller with no companion computer. And as far as I know, this is the first time people have done streaming video through a RG Pilot STM flight controller with no companion computer. And surprisingly, the bandwidth limitation on that is not the flight controller. I've found that the flight controller will happily do 2K video at 30 frames a second, barely ticking over, happily passing through the video in that. The limitation is your LTE modem bandwidth, particularly I'm currently 460 kilobaud because of that level shifting issue. Next to two servers that are actually the Media MTX server and the RG Pilot support server are both running, in this particular case, on the same computer. I've installed them on support.rgpilot.org, but you could easily install this on your own using the nice little setup scripts that Pierre has done. And then you can I've created a little ground station, a web-based ground station I've called Simple GCS, which is a very, very simple ground station specifically designed for my autonomous buoy for the sailing club. So just the features needed for the sailing club. And you can have lots of people connected simultaneously to that, and they get both to the Media MTX server and to the support server. All right, people understand the architecture here now? Okay, so then on this particular vehicle, this is what you're seeing up the front here. And Peter, could I possibly get you to open that door while I show people around? So if we can get that a big roller door open, that'd be great, thank you. And so what I've got on here is I've got a here for GPS, thank you to 3DXR, a Cube Orange, an LTE modem, a BotBlock's drone net Ethernet switch, a little IP camera, Ethernet camera, and this poor little drone is going to be put outside a few meters out so it's got good sky view, please, Peter. Thank you. Pop it out there. And then, so while Peter's negotiating his way out there, I am going to, once it's out there, I'll show you how to all connect to it. So, I have no link to it at the moment. Do I have an internet link at all? Nope. Okay. So flick the power switch off and back on again. So there you go. Of course, you know, the demo, of course, is never going to work, but well, let's see. Let's see if it connects here. And otherwise, if it really won't connect for some reason, probably moving it around. My wiring, as you can see with this picture, the wiring is something that really only a software engineer could love. Quite a bit further out from the... So, Peter, quite a bit further out. Thanks. Oh, I think I lost internet connection here. No, I'm there connected. And so, all right, and let's see if I can connect. So it's been working reliably up till now. And of course, for the demo, let's see why that is not working. Well, how long have I got? I do have 20 minutes, so I can always plug in a cable and debug. Oh, we are getting video there. Okay. And I've lost you. I keep losing internet. No, I think the problem actually is my internet connection on my laptop. I think I'm actually getting... because I actually just saw the video update. Yeah, the support server, I keep losing the link to the support server. Let me just restart that. Okay, now we've got a link. Okay, great. Yes. And so now we've actually got 5 people who've connected already. You're not supposed to have known that the URL yet, but we are having some trouble connecting here. Let's see. Okay, it's connected. All right. So on here, the plan was that I get people to use that URL, and hopefully you can point your phone at it and see if you can connect. And then I'll see what connection you get simultaneously. Is it not working? Not quite up. So if I put it up like that, is that better? Okay. So the URL is also written at the top for those who can't do QR codes. And yes, we are getting the sign-in care, getting quite a few connections coming in. So what is supposed to be happening is you are supposed to be getting a display like this, right? And so I'll just show you around a little bit. Now, can you all see that? So what this is, now this is normally a ground station that is designed for using out on the lake. And so it's a very large area. And I don't have to worry too much about getting lots of timestamp issues. Let's see if we can press here. Right. And manual. Yeah. Okay. Seem to be having... I keep losing link to it, but I suspect it's actually my connection here. Is that video updating? All right. So I seem to have angered the demo gods rather more than I should have. Let's see. So I think some people are managing to connect. What I might do is I might actually switch to using tethering on my phone and see if that works any better. So let me just see if I can get a link if I tether on my phone. rather than going via the conference one. Let's see if that's going to work. I'm sorry? So I've got 66 connections that come up so far, but I don't have an internet connection myself. So if I hit enter, I'm just dead in the water here. So I can't. So I think the drone is connected, but oh yeah, I've got a connection there now. Let me see if I connect, disconnect, reconnect again. So what I'm going to do. So a whole lot of ones there. I connected it with about 50 tabs open yesterday and all worked fine, but now I'm having more troubles. So we've got 29. All right, so we'll have to see if we can. What I'll do again, I'll just try with Firefox demo 2025. No, it's having a lot of trouble connecting. All right. So what I might do is I'll get you to close your tabs and disconnect, and I'll just see if I can get a connection myself. Again, I've just lost internet connectivity again. So my SSH link to the support server is getting lost. And there's a whole lot of connections coming in simultaneously. Lots and lots of attempts to connect, but yeah. Okay. So not working the way I hoped. Apologies about that. The plan was that all of you would be set up here, and those geofences are set up here to show there's the pond right in the middle there, and there's the outer area, which is the safe driveway around it. And what we were doing yesterday is just clicking. So the interface that I've got for this using on the lake with the buoy is just a long press where you want the buoy to go. So the person on the powerboat goes long press, and the buoy goes tootle, tootle, tootle over to that position, then holds position there. And then if you want to move the buoy somewhere else, you just long press and it moves it to another location. So that's the idea. What I don't know is why this is not. And again, my internet connection, my SSHs keep dropping out. So I don't have connectivity myself to be able to go. So I think we are just stretching the infrastructure here with the number of phones connected at once. So I think maybe a little bit too many. All right, too ambitious. So sorry about that. But later, if you want to have a separate demo, I'm happy to with smaller people outside, we'll give more of a demo. So any questions about that, apart from the fact that it didn't work? Randy? Okay, you got the map and you connected, and then you got the streaming video and things. Yeah, if you can connect it all, you should be able to use the inset video and you should get streaming. So try the little hamburger menu in the bottom left, you get streaming video. It should be coming through. Because I think the drone itself, the rover, is connected, because I was seeing video coming up, but all of the Mavlink connections was, I think I might know what it is. I think it may be a blocking, non-blocking socket issue on the support server. Yes, Pierre. I'm sorry? Yeah, it could be the SSL. It could be too many SSL validations going on at once. I'm not sure. I obviously need to do more testing with sort of hundreds of connections, or 100 or so connections. All right. So, okay, so I'll move on to sort of final slide. And so I just wanted to say a huge thank you to the organisers of the conference, to Matt, Pete, and Michelle from KHN Mand, and to Ben and the team for 3DXR, done an amazing job getting this conference together. Thank you so much. And also to BT for loaning us a drone-capable sim, Reese for the Wild Thumper, and of course, all of the ArduPilot partners for your support, and many, many thanks to all of the sponsors of the conference, the ArduPilot partners who sponsored it. So any final questions before I close up? All right. So I'll leave it turned on. If some of you manage to connect, you might even be able to arm it. We'll put it on its little stand so it can't run away too quickly. So
fantastic talk, Tridge. Thank you very much.
Thank you for joining us for the ArduPilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Polybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.